In this video, we're going to talk about inheritance. Inheritance is one of the more important parts of object-oriented programming, although it's often misused. What is inheritance? Inheritance is a form of software use where you create a class that absorbs an existing class's data and behaviors and enhances them with new capabilities. You can designate that a new class should inherit the members of an existing class. This existing class is called the base class, and the new class is referred to as the child class. A child class represents a more specialized group of objects. C++ offers public, protected, and private inheritance. With public inheritance, every object of a child class is also an object of the child's base class. However, base class objects are not objects of their child classes. So, object-oriented programming focuses on the commonality among objects in the system rather than on the special cases. We distinguish between the is-a relationship and has-a relationship. The is-a relationship represents inheritance. A pug is a dog, for example. A child is a human. But you can also say you can let a pug be a type of dog because they do the same thing. Now, composition has a relationship. An engine is not a car. An engine is part of a car. A car has an engine. So, here's some examples. If we had students, some base class would be student. We'd have a graduate student could be derived class. Undergrad student could be another one. For shape, circle, triangle, rectangle, etc. For loan, car loan, home improvement loan, etc. An employee, we can have faculty or staff. We can also have hierarchies of classes. Base classes tend to be more general, and child classes tend to be more specific. Because every derived class object is an object of its base class, and one base class can have many child classes. The set of objects represented by a base class typically is larger than the set of objects represented by any of its child classes. Inheritance relationships form class hierarchies. A base class exists in a hierarchical relationship with its child classes. Although classes can exist independently, and they often do, once they're employed in inheritance relationships, they become affiliated with other classes. A class becomes either a base class, supplying members to other classes, or a child class, inheriting its members from other classes, or both. So here's an example with 5 levels. The university community has thousands of community members. So types of community members could be employee, student, alumnus. We could have faculty, which is a type of employee, or staff, that's a type of employee. We could have an administrator or a teacher, and we could have one that inherits from both called an administrator-teacher. Now you'll notice this seems kind of contrived, and the reason it seems that way is because multiple inheritance is essentially a dangerous idea. Single inheritance, a class is derived from one base class. Multiple inheritance, a class inherits from 2 or more base classes. Modern languages like Java, C#, Python don't support multiple inheritance. It has this idea called a fragile base class problem, and that causes all sorts of nightmares. Actually, inheritance in general has that, but multiple inheritance makes it infinitely worse. Each arrow in the hierarchy above shows an is-a relationship. We can state an employee is a community member, and a teacher is a faculty member. Starting from the bottom of the diagram, you can follow the arrows and apply the is relation to the topmost class. Consider a shape hierarchy. We've got shape, which has 2-dimensional shape, which has circle, square, triangle, a 3-dimensional shape, a sphere, cube, tetrahedron. They both derive from shape, but they are not the same. So we need the inheritance hierarchy contains types of employees in a payroll application, and commission employees are paid a percentage of their sales, while base salaried employees receive a base salary plus percentage of their sales. So let me give you an example here. So in this base example, what we're going to do is we're going to define a class commission employee, which has first name, the definition. It has first name, last name, social security number, gross sales, commission rate, etc. And and we'll define our various methods on it. Then we define another class called base class commission employee, which makes some use of the base class, but by including the base class as a composed object or member. So if we look at the implementation of base class, we see that we end up calling the functions through on the base class. So this seems like a lot of work to do essentially the same thing across two classes. However, there's some real advantages to doing this way too, because there are less headaches. But in terms of inheritance, there's a more inheritance-friendly way to do it. The reason I'm saying it like that is because honestly, inheritance in most cases is overused and abused. There's another type of inheritance called interface inheritance that's actually much more usable and causes less problems. But since we're talking about C++, we can talk about here, we have our base class, our commission class, where we define these methods. Then in our child class, which we call base plus commission, stupid choice for an example, but hey. Here, instead of recasting all of that, we say base class commission employee inherits from commission employee. And so we define our own constructor and only specialized methods, base salary, etc. And we implement in the implementation, we only have to implement the differences. So here we have these things, and oh wait, I'm sorry, this is the base class. I should, and here we implement just the additional functions we've added. Now in main, first, we're going to run this little program that just tests the various things. We've got, we get the informations on the parent class, and then on the base class, and because we've differed in the some of the methods, for example, the base salary method computations, we will see different results. So that's the thing. It basically makes it where we don't have to reinvent all the code. So yeah, we've done both. We created, in the first example, we created a new base class and a base called commission employee, and then base plus commission employee. And since we're using public inheritance, we inherit all the members from commission employee in base plus commission employee. Now, so a couple things. Constructors aren't inherited because they are specific to each class. The public services inherited the constructor and the public methods, and we can't see them because they're part of the base class. They are part of the child class as well. So the constructor introduces base class syntax initialization, which uses a member initializer to pass arguments back to the base class. C++ requires a derived class constructor, called its base class constructor, to initialize the base class. If base class commission employee constructor did not invoke the class, C++ will invoke the default constructor. But since it doesn't have one, in this case we get an error. So looking back at this, we can see that in base plus commission, here we call the base class constructor. Without that, we'd get an error unless there's a default. C++ enforces restrictions on private data members, so even child classes cannot access the base's private data. For that, you have to use either protected or public. One of the things you notice we do, we include the base class header in the derived class because we need the information from it. So when we do that, the compiling process requires object code for all the classes, and also we need to also link in with the standard template library classes we use. So now we're going to take it and tinker with it, use the protected modifier. A base class's protected members are accessed within the body and by friends. So if we come back over here, sample 3, and here we decline. We use public. And we define these as protected. By defining them as protected, base class can still see them because it's one of the base class's children. But only its children and descendants can see it. And the difference in that is that in base class, instead of having to use getters and setters, we can actually use the various methods, the various properties directly. So when using protected data, it creates two serious problems. The child object does not have to use a member function. There's no separation of concerns there. Child methods are often written so they depend on the base class. So what happens if you change the base class? Stuff breaks. This is called the brittle superclass problem, or brittle base class problem, because if you change the base class, you can break child classes very easily. It's one reason to use implementation inheritance very sparingly and with great caution. So, instantiating a child class object begins a chain of constructor calls where the child class constructor, before performing its own class, invokes its base class's constructor, either explicitly via a base class initializer or implicitly by calling the default. If the base class is derived from another class, the base class constructor must invoke the constructor of the next up class, and so on. The last constructor called is a constructor of the class at the base of the hierarchy whose body finishes executing first. So it goes from top down to bottom up. The most derived class constructor's body finishes executing last. So basically, it'll go up the chain until it hits the highest and then come back down. When a child class is destroyed, it goes in the opposite. The object destructor is called. This cascades the destructor calls with the child class's destructor calling destructors of the direct and indirect base class, which execute in reverse of the order in which constructors are executed. When a derived class object's destructor is called, the destructor performs its task, then invokes the destructor of the next base class. This repeats until the destructor of the base class is called and the object memory is free. Child classes don't inherit constructors from base classes or destructors. Child class constructors can call base class versions. When you inherit constructors, each inherited constructor has the same access modifier as its base class constructor. The default copy and move constructors are not inherited. If the child class does not explicitly define constructors, a default constructor is created for the child class. A given base class constructor is not inherited if a constructor that you explicitly define in the child class has the same parameter list. You can't have collisions with parameter lists. The parameters have to be verified. Default arguments are not inherited. Instead, the compiler generates overloaded constructors, so you're not going to get what you think you're going to get there. When deriving a class from a base class, the base class may be inherited through public, protected, or private inheritance. Protected and private inheritance is rarely used because in that case you probably shouldn't be using inheritance. A base class's private members are never accessible directly from a child class, but can be accessed through calls to public and protected members of the base class. So here's just a little chart. We've got public, protected, and private, And in public inheritance, a derived class can be accessed, the base class can be accessed directly from member functions, etc. If the base class is protected, it can be accessed directly by member functions and friend functions. And if it's hidden, you can't see anything. Similarly, protected will only be allowed you access by friends and the base classes, or its child classes. And private, you ain't seeing nothing that's not publicly exposed. Hope that gives you a nice intro into inheritance, and I'll talk to you next lecture.